Hello, welcome to my channel. I'm being chased by the sun here on the balcony, trying to make an early morning video before it gets too bright to film anything. Sorry about all the background noise. You've got a building site across the street as usual. Anyway, the purpose of this video is to look at the noise floor in RNode receivers used for Reticulum Meshchat or for Meshtastic. So here's my little portable Reticulum RNode. I'm going to go and show you this some other time, but it's what is it? It's a rack module inside this box. You can hardly see, actually, it's too dark. It's a sandwich. In the middle of the sandwich is a power bank from Anker. I think it's 13,000 milliamp hours, and on the back is strapped this tiny little router, Wi-Fi router, which is in. They've got a name for the mode. I forgot what it is, but it relays one Wi-Fi network to another, and this is being used to connect the node in here to its own Wi-Fi network. So when I take this out portable, then I've got an access point which I can connect a laptop or a phone to be totally independent of any mains-powered routers, because you need a router when you connect things together with Wi-Fi, usually, to have a little network. Anyway, the purpose of the video is to measure the noise floor, and on the antenna input at the moment I've got it's actually an attenuator, a 20 dB attenuator, but I'm using it as a dummy load, a 50 ohm load. Because it's 20 dB attenuator, that means it'll give 40 dB's return loss, because a signal would have to go out and come back reflected 100% at the open circuit on the end. That's too much theory. The SWR is very low, minus 40 dB return loss. Anyway, this then noise floor, when I measure it, will only register the internal noise in the receiver, and the SX1262 module receiver, which isn't known for its radio astronomy type low noise figure or anything like that. And adding to that, we're getting noise generated here, and because it's not cooled to absolute zero, there will be a little bit of noise generated at room temperature. Very, very small. You wouldn't be able to measure it with this sort of equipment. Anyway, so we're going to look at the noise floor. So let me put this down and switch to the right screen. So I have to turn off that. I'm sorry about that. Look at this. This is the Meshchat program, and the important thing is to click on interfaces. This is the rack node that's inside that box. It's connected via Wi-Fi, and the important figure I want to look at today is this one, which is the noise floor as reported by the SX1262 receiver module. And usually it says minus 114 dBm. I think the Heltec V3 gives a very similar figure. I might look at that later. So minus 114 dBm is the floor of noise. Can't go any lower than that. What I'm going to do, I won't show you when I'm doing it, but I'm going to unplug that load that I had connected to the antenna port, and I've connected a small whip antenna, which I will show you in a moment. And you can see already the noise floor is changing. There's minus 96 dBm. So what's happened is the noise has increased. Let me switch back to the camera so you see what I'm looking at. There's the camera. So it's this antenna. This is actually a half-wave dipole, and here a sleeve dipole. It's like a piece of coax up to here with the center continuing quarter wavelength long, and then a brass tube, which is open circuit at the end, which forms the other half of the dipole. I know this because I took this apart to trim it a year ago because it was cut for the wrong frequency, but it was cheap. Anyway, so it's a dipole, and that is outputting some more noise than just the 50 ohm load. And what I'm going to do is, if I put my hand around it, which you will be able to look at in a minute, you'll see the noise floor goes down on the receiver because the received noise from the surroundings is reduced when I damp the antenna like that. Let's just have a look at that to make sure it works. So there it is, minus 95, 96. Of course, this is changing because there are signals being transmitted on this frequency, and the system here doesn't know the difference between signal and noise, I'm sure, so it's just recording the absolute power level received in the receiver and not caring about whether it's genuine just white noise or whether it's other signals. So minus 95, 96 dBm. I'm going to put my hand around the antenna, and there you see it drops down to minus 106 dBm. So that's like 10 dB's reduction in the noise floor because I put my hand around the antenna to shield it. But it doesn't ever get as low as minus 114, which was with no antenna connected. So you can see that this is really giving a real-time display of the noise floor. I think it's updated every second. That's really useful, I find, because you can check that antennas are working. You can also check that the little device hasn't crashed or something like that, which can also happen. I'm pressing all the wrong buttons this morning. It's early in the morning. There we go. So that's that. What I'm going to do next is connect the bigger antenna, which I was playing with recently in another video. That's this antenna here, which is a 5.8 dBi collinear antenna in a white fiberglass tube. So I'm going to connect that up to here, and we'll see what the noise floor does. What was it? It was minus 96 with this, wasn't it? I'll do it right now while you're watching. So just take that off. Shouldn't do this with the power applied, because if the device transmits, it's transmitting into an open circuit, which is not so healthy for the transmitter, but there we are. There's the cable connected to that white antenna that was on the balcony, semi-rigid coax. It's fairly low loss. I think it's, yeah, about 0.5 dB loss at this frequency I measured the other day. So that's that antenna. Now we're going to have a look at what noise floor is indicated, and oh, it's got better today. Minus 102 dBm, minus 101. So it's picking up less noise than it was the other day, which is interesting, isn't it? But you can see it's changing again because signals are being received on that antenna. And this is the one that was causing problems earlier because the noise floor was so high that the transmitter was inhibited in the RNode. So there it is. I think that's time to stop. I'll just go back, say goodbye, and remember I was playing with this filter as well, and when I put this in, this will reduce the noise considerably outside the frequency range of interest, because the little receiver module in here probably has no filter, not very little, and it's being swamped by nearby frequencies. It was 935 megahertz. There's a big cell transmitter I noticed, which was causing the problems, which is completely removed by this. This gives about 60 dBs of attenuation of that 930 megahertz frequency, and so the node functions correctly. That's enough for now, and let's go and see what I do in the next video. Thank you for watching, and remember to like and subscribe.